This is example 1 of lesson 1.1. We're back at the beginning of a book. This one is ratios, rates, and statistics. And we are doing lesson 1.1, which is just straight ratios. This is example 1, in which we have a bunch of jelly beans. Paul took a handful of jelly beans. He chose 4 blue, 2 green, 3 red, and 3 yellow. Our goal is to write a ratio using each of the 3 ways. And you will have seen on the previous slide that there are 3 ways to write a ratio. There is using a fraction bar, like say 1 to 2. There is using a colon, 1 to 2. And there is using the word 2, as I've just done twice. 1, 2, 2. Or by writing the number, I suppose. 2. Those are the 3 ways you can do it. So we're going to write all 3 ways. So the first thing we're going to write is I'm going to make a table here. So there might be different ways we can write our, reasons we write our ratios in multiple ways. It just depends on your personal preference, on the situation, and what kind of ratio you're dealing with. So, see, this will be fractions. This will be using the x colon y, and this will be x to y. All right, so the first thing we're going to write is the ratio of blue to red. Blue to red. So how many blue are there? There are 4 blue. How many red? There are 3 red. So we're going to do, for fractions, because it's blue to red, we're going to write blue over red, which equals 4 over 3. And just like when we're dealing with fractions, if we can, we want to simplify. Can we simplify here? Well, do we have any common factors between 4 and 3? No. We do not make improper fractions. We will not write this as 1 and 1/3. No, we will not do that. Because while we can write a ratio as a fraction, there is a bit of a difference between ratios and fractions. Now, let's keep going. With using the colon, this is going to be blue to red again, 4 to 3, 4 colon 3. And lastly, 4, 2, 3. And what this means is for every 4 blue, there are 3 red. This does not mean, in the fraction world over here, this does not mean that 4 out of every 3 are red. It's not what it means. It means for every 4, there are 3. For every 4 blue, there are 3 red. Now let's do green to the total. Green to the total. First, we need to figure out how many total we have. We have 4 plus 2 plus 3 plus 3. 3 and 3 is 6, plus 4 is 10, and 12. All right, so our total is 12. Total equals 12. Cool. So, green. How many green are there? There are 2. So it's going to be green over the total, which is going to equal 2 over 12. And this time we can simplify because 2 and 12 have a common factor of 2. So we're going to divide top and bottom by 2. 2 divided by 2 is 1, and 12 divided by 2 is 6. All right, so we're going to use this fraction here, this simplified fraction, in the rest of our ratios. Green to total, that's going to be 1 to 6, and over here, 1 to 6. And what this means is that there is 1 green for every 6 beans. Every 6 beans will have 1 green one if every handful we pulled out had the same ratio. Last one. Red jelly beans to the total. Red to total. Red to total. So, how many red are there? 3. Red over total. And it's going to be 3, 2, same number, same total, 12. 3 to 12 Well, we can simplify that because 3 and 12 have a common factor of 3. 3 divided by 3 is 1, and 12 divided by 3 is 4. So ratio here is going to be 1, 2, 4. All right, and lastly, 1, 2, 4. So when I ask you to write it 3 ways, this is what I mean. As a fraction, with a colon, and with the word 2. And this one means that there is one red for, not one read, one red for every 4 jelly beans. And that's it.